In this video, we'll compare Nginx with a Caddy, a web server and a reverse proxy written in Go. In the first test, we'll use both Nginx and Caddy to serve a static website over HTTPS with default compression enabled on both servers. As always, our focus will be on latency, which we'll measure using P99 percentile. For throughput, we'll check how many requests each web server can handle. To measure saturation, we'll monitor CPU and memory usage relative to the overall VM capacity, as well as network traffic. Finally, we'll measure error rate or availability of each web server. In the second test, we'll use both Nginx and Caddy as a reverse proxies and load balancers to distribute traffic to the applications behind them. Additionally, we'll measure CPU and memory usage of those applications. To run all my tests, I use AWS and the latest EC2 instances specific to the workload I'm testing. For example, in this video, I'll provision M7A large instances for the web servers and the same EC2 types for the applications. I'll also set up EKS cluster with Graviton instances to run my clients and generate load. I also use Route 53 to create private hosted zones for service discovery. I run each benchmark for several hours, and it usually costs between $20 and $50 per test. I use Terraform to create a VPC and all necessary networking components for each test. For the first test, I use Next.js, a React-based JavaScript framework, to generate a simple website and compile it to HTML, CSS, and JavaScript files. Then I create a large EC2 instance for each web server, each with 2 CPUs and 8 GB of memory, and upload the website to each server. I also create a self-signed certificate authority and issue certificates for Nginx and Caddy. To generate load, I create EKS cluster and deploy around 20 pods per web server using Kubernetes jobs. I provide each client with a certificate to authenticate with the web servers. This setup is typical. Both web servers serve static content to the clients using compression to reduce payload size and HTTPS for security. TLS certificates also enable us to upgrade from HTTP 1 to HTTP 2, a more efficient binary protocol. For the second test, I provision 2 additional EC2 instances behind each server using the same large instance type. In this test, each server is configured as a reverse proxy and a load balancer to distribute traffic across applications behind it. Here, we're not using compression because the payload is too small. Each application returns hard-coded data to the client. Additionally, I configure each proxy to pass original client IP address using X404 header. When the reverse proxy receives a request from a client, it terminates that request and initiates a new one toward application using its own IP address as a source. If your application needs the exact IP address of the client, you would use X404 header or configure proxy protocol. In the previous test with Apache, I mostly used default settings for Nginx, which already very efficient. However, I got a pull request from Melroy with optimizations for Nginx, which I applied for this benchmark. I made a few additional configuration changes and tested different thread settings. These changes didn't have much impact on the first test, but they significantly improved Nginx performance in the second test, where I used it as a reverse proxy and a load balancer. This configuration also includes multi-accept setting, and I had to increase open files limit. For the website configuration, I only used port 443 for HTTPS and provided certificate and private key that I generated locally. In the second test, I declared upstream service and used the default round-robin algorithm to distribute traffic to the applications. I also added X404 header, and that's about it for the Nginx. You can find the source code in my public GitHub repo. The link will be in the video description. In the previous test, I used the latest stable version 1.26.2. For this test, I used the latest release from the mainline branch, which is 1.27.2. Now, on the other side, we have Caddy. As far as I understand, Caddy's biggest selling point is simplicity. If you don't want to spend time configuring Nginx, you can choose Caddy, which does everything Nginx does with minimal configuration. This server is also great for beginners. According to documentation, every minimal configuration can represent a production-ready setup for Caddy. So I intentionally used the default production settings to test it. I compiled and used the same website for Caddy, enabling compression as well. I provided my certificate and private key using file server directive to serve the website. By default, Caddy's access logs are quite verbose, so to make it fair, I used format similar to what Nginx and Apache use to reduce the load on the file system. For the second test, I also used minimal configuration with a reverse proxy setting. So in terms of functionality, both web servers use compression and HTTP2 protocol with HTTPS. For Caddy, I used the latest version, which is 2.8.4. Alright, let's go ahead and run the first test. As far as I'm concerned, latency and throughput are the two most important metrics, along with availability of course. At the start of the test, Nginx shows significantly lower latency in serving static website. Based on CPU usage, you can predict which web server might fail first. Memory usage, on the other hand, is very similar for both, around 6% of the total 8 GB limit. You'll also notice that Nginx transmits slightly more data over the network, mostly because its compression level is a bit lower. At around 4000 requests per second, Caddy reaches 50% CPU usage, and its latency starts to increase from this point forward. It's up to you, your use case, and your expectations to define the valid latency for each request. For this first test, I used 1 second timeout, after which 408 status code is returned, impacting the service availability. At around 8000 requests per second, you can see that Caddy begins to fall behind Nginx in terms of number of requests per second it can handle. At this point, latency spikes become noticeable, which I believe may be caused by Go garbage collection, but I could be mistaken. Let me know what you think about these spikes. I don't see them with Apache or Nginx. At around 10,000 requests per second, Caddy is close to 100% CPU usage and falls further behind Nginx. For this test, I deployed Nginx and Caddy on dedicated VMs, so CPU throttling isn't a factor here. Now, let's see how many requests Nginx can handle with a new optimized configuration. It took a while, but eventually Nginx reached almost 22,000 requests per second, nearly the same result as in the previous video with Apache. However, this time it was much more stable. In the previous test, Nginx reached 80% CPU usage and then immediately failed. In this test, even at the same number of requests, it kept running. Let me open each graph for the entire test duration. As you can see, the entire test lasted around 2 hours. First, we have requests per second graph. At around 8000 requests per second, Caddy started to degrade and maxed out at around 10,000 requests per second. Nginx, on the other hand, managed to process over twice as many requests, reaching up to 22,000 requests per second. Next, let's take a look at latency, measured from the client side using P99 percentile. After Caddy began to degrade, we expected higher latency, but let's also look at the start of the test. Nginx was much more stable with significantly lower latency than Caddy. For the client-facing applications, lower latency is important for providing a better user experience. Next, we have CPU usage for both web servers. Web servers are CPU-bound applications, so lower CPU usage generally means a better user experience, lower latency, and higher throughput. Next is memory usage. You can see several spikes, but it stays between 6% and 80% of the total memory available to each web server. So memory doesn't contribute to performance or lack of it in this case. Next is availability graph. You can see increased error rate towards the end of the test, but if you look at the percentage, it's really only 1 or 2 requests out of thousands per second, so it's very small. You might wonder why there aren't any errors for Caddy. Nginx tries to process all incoming requests, while Caddy simply doesn't accept new requests when overloaded. That's why there are no timeouts on the Caddy's graph. Finally, we have network traffic. At its peak, Nginx was able to transmit almost 600 megabytes per second, while Caddy managed less than half of that. If you're a beginner or a web developer who doesn't want to get into optimizing each web server, Caddy is a great choice to start with. If you're concerned about managing TLS certificates, Caddy is ideal, but Nginx offers better performance, making it cheaper to run. I estimate you could save nearly half of the infrastructure cost by using Nginx. Well, it's up to you, but if you're just getting started and using for a personal project with a few clients, Caddy will work fine. Alright, let's go ahead and run the second test. In this test, we'll use each server as a reverse proxy and a load balancer. At the start, I was glad to see that Caddy could outperform Nginx, but this didn't last long. By the time we reached 900 requests per second and only 12% CPU usage, Caddy's latency started to increase. In contrast, Nginx latency stayed flat for a while. What surprised me most in this reverse proxy test is why applications behind Nginx experience so much more load than those behind other proxies. For instance, in the previous test with Apache, it showed the same trend. If you have any insights on this, please let me know. In this test, Nginx memory usage was slightly higher than Caddy's, but memory usage usually doesn't play a significant role in CPU-intensive applications like this. At around 10,000 requests per second, Caddy began showing similar latency behavior as in the previous test. I suspect it's related to the garbage collection, but let me know if you have any other thoughts. At around 14,000 requests per second, Caddy reached almost 100% CPU usage and could no longer process additional requests. You'll also notice latency spikes at this point. Now let's see how much more Nginx can handle. The entire test took almost 3 hours, and Nginx reached nearly 27,000 requests per second. This is significantly higher than in the Apache test with the new optimized configuration. So if you're planning to use Nginx as a reverse proxy, take the time to optimize it rather than relying on default settings. Let's take a look at each graph for the entire test duration. First, we have throughput. Caddy could handle only around 14,000 requests per second, while Nginx reached nearly twice that at around 27,000 requests per second. Next is the latency graph. Looking at the start of the test, Caddy initially performed a bit better, but quickly lost its advantage. Next is CPU usage. Then memory usage. On the availability graph, Caddy's availability dropped as low as 42% in some cases, whereas Nginx only dropped to 99.99%. Next, we have network traffic. Then we have CPU usage of applications behind the reverse proxies. There is something unusual here with Nginx. Let me know your thoughts on this high CPU usage. Finally, we have memory usage for those applications. Now, I see a use case for Caddy as a web server for web developers or beginners. But if you're setting up a load balancer and a reverse proxy, you likely have enough traffic to start thinking about architecture and learning more about web servers and reverse proxies. In this case, Nginx provides much higher throughput with lower latency, make it more cost efficient to run. So instead of Caddy, I would recommend more efficient proxy like Nginx or others. I'll definitely test more web servers in the near future. Thank you for watching, and I'll see you in the next video.